So, this is Earth here, and there are 4 layers of the atmosphere around Earth.
Okay, so here's the first layer of the atmosphere. It's called the troposphere. All the weather and 75% of the total atmospheric weight occurs in the troposphere.
Now, next layer of the atmosphere is the stratosphere. The stratosphere is the second layer from the Earth. The stratosphere contains the ozone layer and
it's vital to our survival because without the ozone layer, we'd all pretty much have no UV protection at all. After that, we have the mesosphere. Now, the mesosphere protects us from most meteoroids by when it goes through our atmosphere, they burn up.
and it is the middle.
Meso means middle in Latin, I believe.
Or it could be Greek or something like that. Then the last layer of the atmosphere is the thermosphere. The thermosphere is made up into 2 sections, which is the ionosphere and the exosphere.
Now, it has no definite shape or it doesn't go out. There's no definite height to the thermosphere, but we know it's there. And that's about it for the 4 layers of the atmosphere. So this is your atmosphere. And there's constant pressure everywhere. Coming in and coming out on all sides. Okay, so inside this chamber is us. We're here. We're under constant pressure. Essentially, we have 1,500 psi on every single part of our body at all times. So, take away the hindrance. Okay, so with our project, we want to make a complete vacuum. So here's our chamber. Inside this chamber is connected a hose and a vacuum. Once the vacuum's turned on, then all the air is removed out of here, and we're putting a balloon in right here. What do you think will happen to a balloon? Well, of course, we're removing all the pressure in there, diminishing the equilibrium. So, in other words, all the pressure inside there is being sucked out, except for inside the balloon. So that gives the particles inside the balloon area to expand. So the balloon's going to come out, 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 out.
Make the balloon bigger. Here. And we got
all the pressure
coming in here. Some pressure coming out. And we have our vacuum chamber, that is right here. And we've got our hose coming out from here over into our vacuum. And
so we turn it on, right?
And wait, we don't turn on just yet. We have to put water in a beaker. It's about this big. There's water in here. And then we turn the vacuum on, Troy. And
let's turn the vacuum on.
Good. Okay. So now, inside the vacuum is relieving all the pressure from around the water,
creating a complete vacuum in this area.
And a complete vacuum is no pressure inside of whatever.
So there's none of this pressure around here.
Is affecting the water. So, in space, there's a complete vacuum, right? And now, in space, water will boil without... Basically, water will boil if there's no pressure on it. So basically what we're doing is relieving all the pressure from inside of it.
Creating it to boil.
Without getting it basically hot. And then when it boils, it creates water vapor inside.
And the water vapor is turned directly back into a liquid, making it continue to boil, boil, boil. So, let's do it, I guess, in the classroom. Start again with our marshmallow demo in the complete vacuum. So,
And so we got our atmosphere here.
yet again. Okay. And as we know, inside the vacuum,
We have all
or inside the atmosphere, we have
all our
all
pressure coming down.
and all the amount, every direction.
So much pressure.
We actually don't feel it. We're relative to it. So inside our big atmosphere, we have our pressure chamber.
And that is in our science classroom.
Yeah,
Right here.
probably like 10 feet away from us. Right?
And we have our hose coming from the pressure chamber. And our hose is going to a vacuum that is right here. And our vacuum, or our pressure chamber, has what inside, Troy?
It has marshmallows actually. So we have all these marshmallows.
It's been a very fun experiment.
Yeah. Okay, so our marshmallows are inside there. Now, as we know, marshmallows have what inside them?
It has
Filled with
air
particles.
trapped inside them.
Yeah. So, what do you think is going to happen when we move all the other air pressure inside it? Kind of like the balloon experiment.
Usually most people think, Troy, that
It's
the
gonna,
marshmallows will shrink down. But that's not really what happens, Troy.
There's a bunch of air stuck inside these marshmallows pockets. So as this pressure is removed out,
So we turn this on right here.
right, these are going to expand because the molecules have more space to move. So all the air bubbles inside there are going to come out
And make the marshmallows bigger.
and make the marshmallows huge. So it's going to be
Ginormous marshmallows.
giant marshmallows. And we get to eat them, I guess.
Yeah.
Okay, here's the lab. Hope you like